So, first thing we want to do is find the volume of a cross-section. I'll draw in a little cross-section here, tiny slice of water, and we see it's a cylinder. We know that the volume of a cylinder is pi r squared h. Volume of any prism is the area of the base times the height. And so here, the base, we've got a circle and times the height. So now, what we've got to do is just plug stuff in. The radius is always 5, that's kind of nice. So 5 squared, and the height is just a tiny, tiny sliver here, and that's going to end up being a tiny change in x, because I'm going to call my x as starting from here and going down. So my height is a tiny dx. So this is 25 pi dx. Now to find your work, I've got this formula rigged here. Now look at my live scribe thing to see how I got this. But once this is for water when we're dealing with, that should be 62.4. Some books round it to 62.5. This is for water when we're dealing with foot-pounds. So if you're pumping out water and you're dealing with foot-pounds, this 62.4 is a combination of it's pounds per cubic foot, and it ends up working. The volume of the ith slice is 25 pi dx, and then the distance traveled by the ith slice, well, if I call x starting from here and going down here, then each slice to get to the top is going to have to travel that x distance. So that's x. And then my limits are always where does the water start to where does the water end. So my water starts here when x is 4.5 and ends when x is 9. Now if you plug this in on your calculator, you will get, let's see, 47385 pi. I don't know why they keep the pi in there, but they do, and that is in foot-pounds. Now, the textbook solution uses a different scale. You have some flexibility. Let's say instead of making this x starting at the top, let's say we made this x starting at the bottom and going up. This is fine too. So you could still say it's the 62.4. The volume of the ith slice is still 25 pi dx. And then the distance traveled, well, this is the distance that each slice has to travel to get to the top. This thing here is the distance it has to travel. Now that isn't x anymore, because this is x. And it's not 9, because 9 is the height of the whole function. This distance is the whole thing, 9 minus x. So the distance each little cross-section has to travel is 9 minus x. And then where does the water start and stop? Well, if x is down here, it starts at 0 and it goes to 4.5. And if you type this in on your calculator as well, you will still get that answer. So if you're looking at the back of the book and you think, oh my god, what did I do wrong? Why doesn't my setup look the same? You do have a lot of play in how you set up your axes. So that's, as long as you kind of know what's going on, that should work.